My name is Johannes Bjerva, and today I'm going to be talking a bit about typological feature prediction and blinding for cross-lingual NLP. So the rough outline is that I'll start by taking a step back and introduce the problem that we're looking at a slightly larger scale. And since typological features and prediction of them is sort of at the core for the potential solution here, I'll spend some time talking about that as well, before looking into whether or not typology in fact could be the solution, based on a couple of arguments, namely that on the one hand, NLP models seem to encode typology, or at least something that correlates with it quite frequently, and that NLP models seem to need typology, as was shown in the recent EACL paper. But at the same time, it seems like adding more typology generally doesn't really help. So we'll look into these few different things. And I'll start off by introducing sort of the big problem here that I'm trying to address in my research in general, and where I sort of think the large-scale potential of this work is, namely in the fact that modern society in general relies on NLP tools. You can think of machine translation, Google search, speech recognition, all of these kinds of different applications. However, as I'm sure anyone at this workshop would be aware, but most languages do not really have access to these tools, nor do we have the resources or the data to create them. And I'd like to highlight that this isn't just some sort of boilerplate motivation that you might find in the beginning of many cross-lingual NLP papers. This really is a big problem. So if you, for instance, look at the UN's Sustainable Development Goals, then there's a target 9C that talks about increasing access to information and communications technology by providing universal and affordable access to the internet in least developed countries. But I would argue that this doesn't help as much as perhaps the UN has aimed for this to help, as it doesn't really give you much to have access to the internet if there's not much for you to do there. If search doesn't work, for instance, or if there isn't much content. So I think the solution here really is, or the problem here really is, that we don't have access to these NLP tools, and that is something that I think typology could be useful for in the long run. There's a couple of causes to this problem, beyond the fact that languages are different, of course, and different things are said in different ways in different languages, which is in part encoded by typology. But also the fact is that multilingual data is scarce, or in this plot, monolingual data available across different languages is also quite scarce. So we can see that high resource languages like English, Spanish, and Italian have a wealth of articles, whereas more low resource languages like Greek and Zulu only have a few hundred or thousands of articles available to them. I'll point out that these are still relatively big languages. There's some 15 million speakers, I believe, of each language, Greek and Zulu. So this isn't just some peripheral problem, it really affects a lot of people. So the question I will ask, say generally in this talk, is whether or not typology might be the solution to the problem. One example of a typological feature is, for instance, adjective noun ordering. So what we have here on the slide is red apple, as we would say in English, putting the adjective before the noun. Whereas in a different language, such as French, this would be something like pomme rouge. Pardon my pronunciation, I don't actually speak French. But the essence being that in French you put the noun before the adjective, usually. And it seems to me that this should be something that could be used. The problem, however, is that we don't really know these features for all languages. So I'll spend a couple of minutes now just talking about the work that I've been doing and others have been doing on typological feature prediction. In general here, we were talking about the World Atlas of Language Structure, which I'm sure many of you are familiar with. It contains roughly 2,500 languages and some 192 features. And here on this map, we see one example of such a feature, the feature for the ordering of subjects, objects, and verbs. So each dot represents a language which is annotated with this feature, and the color and shape denotes the feature value. So these sort of purpley ones are subject, object, verb languages. These red ones here are subject, verb, object languages, and so on. And we can see here that we have a nice spread across the entire WALS, and that is indeed also what WALS aims to do to some extent, to have a nice typological representation. So WALS encodes all sorts of different typological features, for instance, on syntax, morphology, phonology, and so on. I won't go into the details here, but the problem that we have in WALS is that although we have all these features, WALS and other typological databases are relatively incomplete. So if we here have a plot showing the languages annotated in WALS sorted by the rank of how well annotated they are, which is how many features they have annotated. And here on the y-axis we have that number. So for instance, the most well annotated language has some 150 features. Whereas when we get down to language number 500 or 1000, we only have 40 or so features available. This is of course a problem if we want to be able to use these features for some sort of NLP application down the line. And I would like to highlight that the problem is even worse than it might seem here. This covers some 2,500 languages or so, but depending on how you count, I believe Harald Hammerstem had a keynote about this at the last SIGTYP workshop, but there are some 6,000 plus languages in the world. You'll have to look at that keynote for the exact number that he comes up with. So since these databases are incomplete, we need to have some way of predicting these features in general. And one way of doing that is, well, for one, look, it's difficult because languages are different. So for instance, in English, a verb phrase might have this structure where we say eat an apple, so putting the verb before the noun phrase. Whereas in a language like Japanese, this would be the other way around, putting the noun phrase before the verb. However, when it comes to prediction of such features, we are lucky in the sense that these features can, they typically correlate with one another. So for instance, if we say go to SIGTYP in a verb-object language, such as English, then in an object-verb language, such as Japanese, this would typically also be the other way around. So the difference being that in a verb-object language, you would typically have a preposition, and in an object-verb language, you would typically have a postposition, saying SIGTYP to go, effectively. So we know that we have these correlations. This is well established, for instance, via Greenberg's universals. But when we look at the data, we can see that these typological correlations don't hold 100%. So if we look at Indic languages, we can see that the pattern holds. Object-verb languages tend to have postpositions, such as Japanese. In the case of oceanic languages, we see that the pattern still holds. So verb-object languages tend to still have prepositions, mainly, at least. But in Semitic languages, we can see that languages are fairly, say, evenly split between being verb-object and object-verb. However, they are almost all prepositional. So that's to say that even though we have these correlations, they are rarely 100%, and the problem is a challenging one, it would seem. So just to make it very explicit what the task is in typological feature prediction, we would typically have an input. For instance, here we have an example from the SIGTYP 2020 shared task dataset, where the input is a language with some metadata, for instance, the language code, name, genus, and family. And the goal is to predict these, say, question marks here. For instance, what is the subject-object-verb ordering of Marathi? And as you would expect, the goal is then to predict the correct label down here. Now, what we've shown in some previous work is that the task is not too difficult if we do not control for some things. So one thing we took care to do in the SIGTYP 2020 shared task is to control for both language relationships and language proximity. Because as we showed in 2019 NACL paper, if we have access to a lot of in-family language data, then the task becomes relatively easy to solve. So what we did here in the SIGTYP 2020 shared task was, on the one hand, to control for phylogenetic relationships, and on the other hand, to control for geographic influence. When I say control for phylogenetic relationships, what I mean is that, for instance, if we're evaluating on a language such as Dutch, then we would not have access to any other language information from that same genus or from the same branch. Or in, say, various steps, we would have access to some information from these languages. When we talk about geographic influence, what we did was essentially make it so that each test language, for instance, here we have a cluster of test languages, would be 1,000 kilometers removed from nearby training languages. So we've held out a lot of languages in this region surrounding here. And the idea of that is that we would often there is often geographical influence, which can also influence these typological factors. So if you want to evaluate typological feature prediction on Romanian, it's probably not a good idea to train on languages surrounding there, even though you've probably held out other Romance languages. That's still not enough, potentially. So just a very brief look at the results, just to show that this was a challenging task. However, different teams did manage to get very nice results for this shared task with an average accuracy of 75% for the top system. And we can see that across the different held out language families we had, the performance is generally, say, across the board, relatively high. But like I mentioned before, if we have sufficient in-family training, which I would say in NLP settings we often would have, at least in the current state, then we see that the task is, say, relatively easy to solve. And this is a plot from a NACL 2019 paper where we looked at typological feature prediction. And here on the x-axis, we can see that the more in-family training data we have access to, the higher the F-score gets, and we can get almost perfect predictions when we have, say, enough data available. So the takeaway from this first part is essentially that typological feature prediction, well, you could say it's solved when we have enough knowledge of related languages, but in a more realistic setting, perhaps, or in a challenging setting, it is a difficult problem. Unsurprisingly, we saw that rare features are difficult, where the best systems still only had an accuracy of around 65%, and the worst systems were essentially guessing. I think the real future here is, beyond just trying to get higher accuracy, is to look into things such as explainable modeling of typology. I think it would be very interesting if we could have, say, a typological feature prediction system, which would also point out on what basis it's made these predictions. So this would be more similar to the unconstrained setting from the SIGTYP 2020 shared task, where, for instance, a system could have looked at a whole lot of multilingual text. And I think it would have been really interesting to see a system that would say, okay, you know, we predict that this language has so-and-so many consonants, for instance, based on the script, even though there's not necessarily a one-to-one correlation there. Or we can say that this language seems to be highly suffixing based on these patterns in the data. I think this would definitely be much more useful, and my impression is that typologists are a bit, suspicious is not the best word, but it certainly would be easier to convince typologists of the use of this kind of system if we had explainable models for this. So this brings us to the potential solution to this big problem that I set out in the beginning. Since we are able to predict these typological features for at least a large portion of the languages in the world, could it be that typology is the solution? So here I'll go through a couple of arguments. On the one hand, looking at some examples of how NLP models seem to encode typology or something that correlates with it. And it seems like NLP models rely on typology to some extent. So why don't we just add some more typology to our models and see how that works? Sort of putting the cart before the horse here, I'll mention this idea we had in an upcoming StarSem paper, which I at least think clearly shows that there is a lot of potential in using typology for NLP. So if we go back to the red apple example I had, here we have a sentence in English, she's eating a red apple. And here is a corresponding sentence in French, elle mange une pomme rouge. Again, apologies for my pronunciation. Now, if we add an alignment between these two, then obviously we will see that all is well until we get to, say, the one case where we have a typological feature that differentiates the two from each other. So here we have a mismatch in the alignment. One of the ideas we had in this upcoming StarSem paper was to quite simply see if we could sort of fix this typological difference. The idea being that we wanted to try to decrease, say, the linguistic distance, if you will, between two languages, and see if we got any improvement on different NLP tasks by doing that. And of course, this is not a grammatically correct French sentence anymore, but we've seen that word ordering doesn't necessarily matter so much for instance, masked language models. So perhaps this might be useful here as well. And lo and behold, indeed, we see that at least for 3 languages, unfortunately not a very big typological range for this workshop, but 3 languages which have a different adjective noun ordering than English, we can see that across the board we get high performance when we make this modification. And this is evaluated on 2 tasks, XNLI and a reference-free machine translation task here. So I at least think that this shows that there is a lot of potential for using typology in NLP. And the question is just, how can we do this the best way? But I'll go through a couple of arguments still to say why I think this is so important for NLP models. What we've shown a couple of years ago and what's been shown in various probing studies as well is that NLP models seem to encode typology, or at least something that strongly correlates with typology. So I'll show you a couple of examples here. On the one hand, looking at sort of typological prediction from language representations, sort of probing-like study, and also looking at task-dependent changes in language similarities. So here I'm talking about language similarities in the, say, embedded language spaces that are learned as a byproduct of these tasks. And we'll also talk about this figure when we get to it later. The general experimental setup that I'll have in this part is sort of inspired by the language representations that were trained in Östling and Tiedemann in the EACL 17 paper, where they essentially have a multilingual language model, which on the one hand learns a language modeling task, but as a byproduct, it learns a language embedding. And apologies for using flags to represent languages in this talk. That's generally not a good idea, but I hope you'll bear with me and I'll try to just say what language I mean rather than only having the flags. So here we have an example of a character-based language model for Dutch. So the input at every level is a Dutch language embedding, which is learned during training, and the symbol that we have so far. And the goal is, of course, to predict the next symbol here, the string cuts in Dutch. The idea being that if we train this model on a whole bunch of different languages, we get this set of language embeddings where we should have some interesting properties. For instance, that the language embeddings might encode language similarities somehow. In this case, we have a nice Germanic cluster with English, Dutch, and German up here, and a Finno-Ugric cluster down here with Estonian, Finnish, and Hungarian. So that's step 1. And the next thing is to look at how these language embeddings then might be used for typological feature prediction. The idea being that if we can use, if language embeddings trained on a certain task are good at predicting a certain type of features, then it seems like this feature is important for that task. So if, for instance, if we learn language embeddings in syntactic parsing, and the resulting set of embeddings is good at predicting syntactic features from WALS, but not at predicting phonological features from WALS, then perhaps we could argue that syntactic features in WALS are relevant for syntactic parsing, which would not be the most surprising result, I suppose. So I'll give you a couple of examples of what we did here. On the one hand, looking at phonology, we looked at a set of 20 phonological features from WALS and the task of grapheme to phoneme translation for a set of 102 languages. And the task is essentially to go from a language and a string to its, say, phonological representation, a phonological transliteration of that string. So here we have an American English, I suppose, translation, variation, something along those lines. And the similar string with French should be variation or something like that. And as I mentioned, the idea being that if the model trained on this phonological task and learns language embeddings along the way is better at predicting phonological features, then we could perhaps argue that these features are themselves relevant to the task. And that is indeed what we see. As compared to all other features in the data set, the model is, the language embeddings are much more appropriate or much better at predicting phonological features than they are predicting other features. In a very simple setup with, I believe, k nearest neighbor with k equal to 1, if I remember correctly. So I would say this shows that when we learn language embeddings in a phonological task, then it seems like those embeddings represent sort of the phonological similarities between the languages in a way that reflects their typological properties as well. Next, we have an example on morphology here, where we again look at some morphological features from WALS, and we're using SIGMOR from 2017 data here, only on 29 languages, however, as we had some other constraints. But the task is essentially to go from an input string and some morphological features to the inflected form. So this is a task of morphological reinflection from SIGMOR from 2017. Again, we see that a model trained on a morphological task, this was a relatively simple model at the time, I believe a BILSTM of some sort with attention. And we learn language embodings as a byproduct. And again, we see that the model trained on this task is better at predicting morphological features than it is at predicting other features. So I think we've there shown that at least it seems like these language representations learn something that's relevant for the task at hand. And here I want to look at a different example at similarities, showing the similarities between language representations and how they change. And what we've seen is that also language similarities shift depending on the task in a way that seems to mimic these typological properties. So for instance, what we have here on the slide is on the y-axis, we have the difference between these three different language embeddings and the embedding for Norwegian bokmål. If you're not familiar, I can mention that Norwegian bokmål is, as compared to Danish, very, very similar. They were the same written language some 200 years ago. And although there are differences, it's possible to read a whole sentence and not know which language you're looking at, for instance. So since the offset here, the starting point here is language embeddings which are trained on language modeling. It's not surprising that Norwegian and Danish are here represented with almost the same embedding, or at least very similar ones. However, what we see is when we train on a phonological task in this case, once we get to iteration 1500 or so, it seems the model learns that it's not a good idea to cluster Norwegian and Danish together anymore. And we can explain that quite simply by the fact that the phonological features of Norwegian and Danish are surprisingly different, considering how similar languages they are in other ways and mutually intelligible depending on exposure, I would say. Similarly with these two other embeddings, we see that the differences just get larger in general. Also, we looked into what these sort of language representations generally seem to represent, and what we found also goes in support of this sort of task-dependent relatedness, I would say, in that we found that language embeddings typically don't seem to encode family distance, for instance, but rather the structural distance between languages. And we looked at this in a setting where we looked at language embedding similarities in settings with, say, standard language modeling over function words, language modeling over strings of part of speech tags, or dependency relation tags, and so forth. And what we generally see is that these, in all cases, we see a strong correlation with the structural similarity. The structural similarity is based on, say, dependency relation statistics from the universal dependencies. I won't go into the details here, but if you're interested, there's the CL paper from a couple of years ago to look into. Furthermore, along these lines, we can say that if we look at language relatedness under different tasks, language similarities on different tasks, then we see that under the task of language modeling, English is clustered together with, shall we say, Romance languages like Spanish, French, and Italian, which makes sense because of a lot of shared vocabulary between these languages. But when we learn a task of part of speech tagging instead, then English is clustered with Germanic languages, which might make sense in terms of syntactic similarities there. So I think, at least I've argued that NLP models seem to encode typology, or at least something that correlates with it. For one, because language representations can predict typology, and task-specific representations are better at features that should be relevant to that task. And also because language representations evolve across training to make typologically similar languages more similar to one another. Where, for instance, phonologically phonologically dissimilar languages seem to diverge in this phonological task here, and syntactically similar languages converge conversely. So for the next part of the argument, I would like to talk a bit about this work we've had at EACL now, where we more or less show that NLP models seem to need typology, or at least if you remove typological features which seem relevant for the task at hand, then performance drops. Our general question here was whether or not we could find a way to force a model not to use typology, so we could see whether or not it was important to them, sort of based on the fact that most past work hasn't really shown any consistent gains in trying to actually use typology to get better performance. In this work, we were inspired by domain adversarial networks, and we adapt this to a procedure that we talk about as blinding, or typological blinding. In addition to this, we use a sluice network for cross-lingual sharing in our experiments, and I'll go into the details of what's interesting about that later. But essentially what we do is that we introduce this auxiliary task that we base on typological feature prediction, however, with an optional gradient reversal weight on there. So we have, in essence, this, for instance, in this case, a model for part of speech tagging. We are in this case looking at an example with only Spanish and French. The idea being that we have a multilingual BERT model, after which we have some language-specific parameters which the model can use to share between the different languages in the model. The interesting part is that we have these alpha weights which the model learns itself, so it can itself, could you say, choose which languages it wants to share more with. So we could imagine that the model might learn to share more between typologically similar languages, for instance. Adding this auxiliary task allows the model to have some idea what discrete typological features it is we're looking at. And in addition, with this, with the addition of the gradient reversal, we should get some insights into whether or not typology is actually important to the model. So the idea being that if the sharing is affected or if the performance is affected, then we've done something, at least. So just for a couple of more details on the gradient reversal layer here, or the typological blinding. In the original formulation, the goal is to get domain invariant features with respect to these parameters here, with the idea of getting as similar as possible feature distributions here, regardless of the domain that you're looking at. So this was using a domain adaptation setting. In our formulation, we want to get feature distributions which are as similar as possible regardless of the typological features that we're looking at, or the class of typological features. And our hypothesis is here that if the model relies on typology, then making it unaware of these features will make performance drop and will affect how the model shares between different languages. We have a couple of experimental conditions. We're looking at blinding versus prediction, so with or without this gradient reversal part, as well as a baseline, of course, where we don't have this auxiliary task in here at all. We're in addition to this looking at a couple of typological categories. We're looking at syntax and morphology because we hypothesize that these should be relevant for the tasks we're looking at. In addition, we look at phonology and genealogy, or family relatedness, as sort of control experiments, with the idea that these two should not be relevant to any of the tasks that we're looking at. Finally, we look at a few different NLP tasks: named entity recognition, part of speech tagging, and NLI, XNLI, in up to 40 languages from the extreme dataset. And it's WALS features in general that we're trying to predict here. The research questions that we looked into is, on the one hand, how is the model's performance affected by blinding and prediction in general? For instance, does the type of feature that we blind to affect the results in any particular way? For instance, if we blind to a syntactic feature, does that decrease performance on tasks that require syntax? Similarly, how is the sharing in the model affected by this? For instance, does the model represent syntactically different languages, syntactically similar languages differently under syntactic blinding? Jumping straight into the results, we can see that in the different prediction settings, syntactic prediction, morphological prediction, phonological and genealogical prediction, we don't really get any consistent changes from the baseline here. So 0 here is the baseline, and we are measuring the change in accuracy for each language with respect to this. However, when we try to blind the model to, for instance, syntactic features in WALS, we see a substantial drop in performance, and this is on part of speech tagging, I forgot to mention. Similarly, for morphological blinding, we also see a significant drop in performance. Now, a fair question to ask is it not just the case that we messed up our model by using this weird sort of blinding task? But luckily, our control experiments on phylogenetic blinding and genealogical blinding show almost identical relationships, almost identical results to the prediction task. So it both shows in these final settings here that our control features are not relevant for the task in any way, and therefore also not enough to ruin, shall we say, the results. So that answers the first research question, as we've now seen that a task that seems to require syntax and morphology, like part of speech tagging, we get worse results when we blind the model to these features. And brings us to the second question, whether or not languages are actually represented differently under this blinding condition. So the reason why we can do this is because we have these alpha parameters in here, which more or less denote the extent to which the model shares between, for instance, in this case, Spanish and French. What we see is that in a syntactic setting, using syntactic prediction increases the similarity between syntactically similar languages, whereas with syntactic blinding, the similarities between syntactically similar languages is less. So in a blinding condition, the model chooses to share, shall we say, in a potentially inefficient way. And this sort of is a similar result to what we had with language change across different tasks, that here in a part of speech tagging task where we should have a high syntactic similarity between languages in order to be successful in the sharing, the blinding sort of messes that up, to put it that way. So I would say it seems like NLP models encode typology or something that correlates with it. It seems like NLP models need typology. So why doesn't it really help to add more typology to our models? So just to look at a very brief sketch here of what I mean. This is just a sketch model, but one way of adding typological knowledge is to simply include it as features, of course. But it seems in general as if this doesn't really make much of a difference. For instance, there's an interesting paper by Modena and Onsevai at this workshop, which should discuss potential ways of adding this to machine translation. And while they have some interesting results and some interesting gains here and there, it's hard to get anything that's very consistent. And for parsing experiments on this, I can highly recommend checking out Miriam's keynote at this workshop, where she talks a bit about this aspect as well, and some cases where you do get some positive results in some settings. And we have some ongoing follow-up work looking at how this could be done in a different way. Finally, a different way of doing it could be to incorporate typological knowledge as an auxiliary task. And apologies if the video is hiding this, but here we have an auxiliary output for prediction of WALS syntax down in the bottom right. However, here again, we see that this doesn't really make much of a difference. For instance, in the experiments I just showed from the EACL paper, we don't really get much of a difference in this setting. So direct incorporation of typological knowledge doesn't really seem to work so well. However, there are some papers showing that indirectly trying to incorporate this does work. For instance, there's a very recent paper, it's on arXiv, I'm not sure if it's published anywhere yet, where they look at trying to predict beneficial language pairings. And they do indeed find that this seems to be possible, but it seems like it doesn't necessarily fit the typological expectations you might have. For instance, the best source language for Bulgarian is French in part of speech tagging, whereas in named entity recognition, it's Russian, which might make some sense. But then when you go to natural language inference, for some reason, Thai is the best source language. And the question is whether or not this has anything to do with typology or if it's some artifact from translation or something along those lines. So this is sort of, I suppose, a disappointing keynote in the way that I don't really have an answer to this big open question, namely, how can we best inform models of typology? And I certainly think it is a solution, at least based on this recent work that we have at StarSem now, where we see that sort of reordering based on this typological intuition helps. And we get increased results across a whole host of languages. Yes, what is the best way of incorporating typological knowledge in an LP model? I think that's an open question. It's something I'm working on at least, and hopefully at an upcoming workshop I can have some better answers to that, but I think make for an interesting discussion now, if nothing else. So thank you very much for your attention, and a big thanks to all my collaborators. The work I presented here today has mainly been based on these different papers here, and yeah, without the great collaborators, this certainly wouldn't have been as realistic. So thank you very much.